Right. Okay. So this particular problem set was just to get you familiar with the manipulation of the block diagrams. Okay, as usual, if there's anything that you need clarification on, just catch my attention. I'm trying to monitor the chat here, but I may not see everything, so you have to say something. All right. So let's go through it. The main one that sort of checks everything that we spoke about is really question 3. All right, and we'll talk about that. So question 1. If you look at question 1, anybody had any issue with it? And let me just comment here. Right. One of the things with looking at the block diagrams is that you remember we always trying to get, and I hope the marker works here. We always trying to get to simplify whatever we do to get it into a simple negative or positive feedback block, right? Okay, whatever. This is positive. Seem to be having some issues here. Okay, so positive, negative. This is the G, this is the H, right? And once we get it into this form, we know that the final answer is going to be a G over 1 plus GH. So if you look at this diagram here, one of the things that you have to be able to look at with the block diagram simplifications is to notice if the diagram is drawn exactly how we want it, but maybe inverted or upside down. And if you look at this one, you'll realize that this here, that is a negative feedback block, but it's sort of left or right. So the input is here and the output is here, right? And the feedback, of course, is coming through from output to input. So once you recognize that, then you can simplify this. This is the forward block. This is the feedback block. So the output, the input output of this is going to be H1 over 1 plus H1, H2. And once you get that now, then that particular entire block, which is H1, 1 over 1 plus H. Okay, this isn't working this way. 1 plus H1, H2. Then the entire simplification now is just G over 1 plus G times that. In which case you're going to get that answer on top here. Yeah? I mean, this is very straightforward, but anybody looking at it had an issue with it? Right, so the solution for that, right. So the solution, as I say, look at the diagram, see if that you have the feedback block either inverted left or right, input, output, swapped or something like that. But once you have it there, then the rest is fairly straightforward. Question 2 doesn't have any feedback at all with it. And this was another situation that you tend to meet occasionally when you're simplifying the blocks. You're simplifying this block diagram, but it has no feedback in it. This is all feed forward and summing. So for instance, if you look at X here, right? X is really R by G1. And what is coming out of here will be X plus RS. I'll just call it R. So in other words, coming out of here is this plus R. And that is going into G2. So coming out of G2, coming out, oh, the whole thing changed. Coming out of G2 will be this now multiplied by G2. And then CS now is that plus R. Okay? And you could open up the answer. So the final solution is just a set of multiplications and additions. So the reasons really for the first two problem sets were one to understand that if you have like feed forward in this case, all you have to do is just simply, if you have this, like this is something plus something, then that's all it. Whatever it is here is going to be added to that. There's no feedback loop inside of here. Okay? This signal is going here, this signal is going here, or it could have gone anywhere else. You just trace it back. And the combination of those two manipulations, this and looking at this sort of reverse manipulation that we had on top here, is usually what you typically need going forward. All right. Now, this brings us now to this sort of practical example of the kind of things that we ask and that you will have to solve. So we have this one, and you can simplify this diagram, and there are two ways to do it. One of the things you have to remember, there are some manipulations that we can do inside of here. We could take blocks, summing junctions, and we can move them before or after a block. So you can take a summing junction, and I can move that summing junction before G1, or I can move it after G2. Okay? Takeoff points, I can similarly move before a block or after a block. So I can move that takeoff point before G3 or after G4. What I can't do is to swap takeoff points on summing junctions. So I can't move a takeoff point after a summing junction, or take a summing junction and move it before a takeoff point. Okay, that is not permitted. What we can do is to move the summing junctions before or after blocks, and we can move the takeoff points before or after blocks. The other thing is that summing junctions, for instance, if I took this one here, and I moved it here, I could equally move it here. I could swap the positions of summing junctions. Because if you think about it, if I have something like this is plus, this is minus, and let's say this is plus here and plus here for argument's sake, right? You realize addition and subtraction are linear operations. So if this was if this was A, B, and C coming in inside of here, A minus B plus C, right? A minus B plus C is the same as A minus C plus B. Sorry, it is the same as A plus C minus B. Yeah? So for instance, let me just stop this share for a second and share. All right. So if I have something this plus minus plus minus, right? So A, B, C. Okay. This point here is A minus B. Seem to be having a lot of problems with this. Give me a second, half a second. Let me see if I can solve this for a second. Right. The point coming out here is A So A minus B here, and then at this point here, it is A minus B minus C. Right now, I could which is A minus B minus C. Now I could do this in any order. So I could have swapped these blocks and arrange it like A minus C minus B. All right, it doesn't matter because of the linearity of addition and subtraction and so on, what order I do this in. So I could actually swap summing junctions, and likewise, I could also move takeoff points. We saw this. So if I have something coming here, this is going here, this is going here. It doesn't matter if this takeoff point is this way, or if I put the takeoff point, if I move this one after here. Okay? You don't make a difference. So once you remember those things, that you can move the summing junction before or after a block, you can move a takeoff point before or after a block. I could swap summing junctions and I could swap takeoff points. Then once you do that, then the manipulations become fairly easy. Okay, 1 second. Right, so let me stop sharing this and go back now to the solutions.
Excuse me?
Yeah.
So why in that explanation you're using just now was not plus C?
Sorry?
In the explanation that you were giving just now with A, B, and C, why was it minus C and not plus C, as there was like a plus at the junction?
Hold on, let me see if I can get back that whiteboard again. Right. So I have coming out here is A minus B, and is A minus B minus C. If I open the brackets, there's no change, A minus B minus C. There's not a minus sign in front of this bracket here, you know.
So I meant like from the diagram that you made originally, like on the top right left-hand corner, as there was like a plus sign at the junction going into C.
Oh, and I was just using that for argument's sake. So if we had plus C here, then it would have just been plus C here. Right? In other words, so if you open this, it would be A minus B plus C. And then in that case, I could have had A plus C minus B. In other words, I could have had a summing junction looking like this now, which was A here, C, and then going in here. And if we have to have minus B now, I'll have B here and have a minus here and a plus here. Right? So in other words, I could swap these two situations. Yeah?
Yes, thank you.
Okay. Right. So let's look at the solution for that particular one now, because there were two ways you could do it. You could take that one. And as I mentioned before, not all of the block diagrams have a unique solution. You can arrive at it in different ways. Right. So the particular diagram to simplify is the one that is there. And as I said, there were two ways to do it that I saw initially. There may be another. I'm not too sure. But sometimes with the block diagrams, you have multiple ways of solving the same diagram. You just have to take care. And one of the things I'm going to tell you, like I mentioned with other things, like the convolution and so on. And then later on, when we do this stability lectures, don't be afraid. Rewrite every time you recompute the answer, rewrite it, or in the case of a block diagram, draw the diagram over. All right, so here we go. We started off with the diagram, and the first step, of course, if you look at this group here with G1, with G3, 4, and H2, you notice that that is a nice feedback group, except for the fact that we have a takeoff point in the middle of the two blocks. So the first step, we are allowed to move takeoff points before or after blocks. So I can move the takeoff point to somewhere beyond. And as I said, what you want is to be left with a feedback block. So I move it beyond this other takeoff point here. So step one will be to shift this takeoff point after G4, right? Once you do that, now, of course, we have to put in, once I do that by moving it after, I have to put in a block here to compensate for the fact that if I move it after, whatever I'm taking off from here was multiplied by G4, so therefore I have to divide by G4, and we went through that. So if I move the first block, the first takeoff point past G4, then I am in a position now to simplify that feedback block, set of blocks, say it's a negative feedback, positive, negative. So if I do that, I'm going to get in that, replacing that group of blocks would be G3, G4 over 1 plus G3, G4, H2. And then because I move the takeoff point, I have to divide H3 by G4 up here. Because I moved it here, I have to put a 1 over G4 here. So in other words, this now becomes H3 over G4, right? So the next step now is, of course, we want to try to get this thing. If you look on top here, the G2, this new block here, and this one here, again, are all in our feedback loop, except for this takeoff point. So step 3, we shift the takeoff point again. All right. If I shift the takeoff point from here to after, I'm going to have to put in a block that is 1 divided by whatever the transfer function of that block is. If I do that, oh, and this was the point I was making. After you did the first step, draw over the diagram, right? So I've redrawn the diagram now to show what the simplifications of the first 2 steps were. Then you make this change, redo the simplification, and notice that the feedback loop is a positive feedback loop. Positive. So it's going to be, and what is a forward block in the loop? This is the forward block. This is the reverse path. So it's going to be this, whatever this simplifies to be, over 1, because it's a positive feedback loop, 1 minus this divided by that. Right? And this is where it starts to get a little bit long. So the feedback loop, when you simplify it now, you eventually get this and the negative sign coming up because it's a positive feedback loop. So this is what they, after you've done the 2 sets of simplifications, and this is now your regular negative feedback loop. So these 2 combine, so it is G1 by G2, G3, G4 over all of that, over 1 plus, because it's a negative feedback, 1 plus that multiplied by that. All right. And as I say, if you do it, it gets a little bit long and tedious and so on, but eventually you'll end up with the answer. All right. When we're doing the problems like here, or you might get in another problem set or in the exam and so on, usually you would not get like a G2 squared or H3 squared or something like that, right? But because it's just, sometimes it's just manipulation to see if you all can do the manipulation, you may get these oddball behaviors happening. In real life, you're not, when you're modeling, when you're doing this in controls or advanced controls or wherever you're encountering this later on, you're not going to ever get a G1, G2 or something squared. All right? If you ever get that kind of thing, it means that there's something wrong with the model or something that was wrong with the simplification. Okay, so just keep that for going forward in later courses and later on. All right? Okay, so that was the first version. Anybody tried it that way? Yeah, no? Right? So, and if you look at it, and this is what happens sometimes when you look. If you look at the problem, sometimes you can see a simpler way of doing it. Not always, and there's no penalty for doing it the long way as against doing it the short way, all right? But look at it again. This is the problem that we have here. And notice that if I step one, which is where we started, to shift the takeoff point from before G4 to after G4, which was the first step that we took in the last approach. And then the second step to shift this summing junction from after G1 to before the first summing junction. If I do that, then what I land up with is two simpler negative feedback blocks to work with, and then the overall positive feedback block on the outside. All right. And the point I was making here is that the summing junction move is possible because it does not matter what order summation is done. And summation includes summing or finding the difference. Right. So because I was able to make this move, I could move this block, sorry, this summing junction across here. Right. So I'm jumping G1 and I'm also swapping the position of the two summing junctions here. Then I am left, and you redraw the diagram, I'm left with this feedback block, which is easy to simplify. I'm left with this feedback block, which is easy to simplify. So you do the two, and then you multiply them together, and then you do the overall positive feedback block here. Remember the signs. Always look for the signs on the diagram, where may be a positive feedback, where may be a negative. And if you do it, right, you land up with the same solution. At this point, the answer doesn't get you still will be somewhere land up with something looking like this that you have to simplify. But the approach is a little bit easier. Yeah. Did anybody try and have another approach? Or is there any thing about the moving of the blocks here that that you don't understand? For instance, I cannot interchange these things. All right. Okay. I can't swap those two things. I can move this block here. I can move this takeoff point here. But kind of like if you're playing chess or you're playing drafts or something, so you can't, there are certain moves and places that you can't go with a piece. Well, it's the same sort of thing. You can't take this piece and jump this one here. That's not allowed. But you could take this and jump here. You could take this summing junction, sorry, this takeoff point. You could move it here. You could move it here. You could swap the positions. You take the summing junction. You could move it here. You could swap the position with another summing junction. All right. And those are the manipulations that we are allowed to do. So we okay with that?
Good morning.
Yeah.
So I just have one question, right?
Mm-hmm.
So with regard to the feedback loops, let's say for the first one where we have each one, right? right now that would be a negative feedback loop. But what
Correct.
if it was positive?
Well, it was
What the expression would be?
You remember we worked on that. So the negative feedback loop. So for instance, let me see if I can draw this somewhere here. Yeah, my stylus doesn't work good with PDFs, unfortunately. Right? So GH. So if we have something like that, if the feedback is negative, we know that the overall transfer function is G over 1 plus GH. And there was a problem set, and we also did it in class. If instead the feedback is positive, then this sign becomes a negative. So it's G over 1 minus GH. So negative feedback gives you a positive sign. Positive feedback gives you a negative sign below there. Yeah?
Yes, thank you, sir. Just wanted to be sure.
Yeah, go back to the lectures on the block diagrams. You'll see we did it early on. We're somewhere inside of there, or in discussions when we did it here, or when we were talking about positive feedback and the effect of positive feedback here. All right. Okay. Question. Actually, I had this because last time this was the solution from last year. We actually simplified this particular problem in class, but it's the same thing. This is a negative feedback. Let me just get back the question here. Right. So this was, we're going to meet this again in a couple of weeks. But here's a simple thing, determining, this was part of a question. Actually, the later thing that we're going to come up with, the later topic is that K, and is a question of what value of K makes the thing stable. And we're going to talk about that. So this was a block diagram from something that is coming up. Last year, the midterm was a little bit later on, so we had already done this part. But this is a simple feedback block again. This is G and H, negative feedback. So it's G over 1 plus or minus. Which is it? Negative feedback. So it's plus or minus. Which one? Plus, right, there you go. Right, so know that automatically G over 1 plus GH, and you simplify. Right, and the last one, this one again is just where you're simplifying this diagram again. So the overall thing will be, this is G1, this is G2, this is H1. So the forward block is G1, G2. So the overall transfer function, check the sign here, is G1, G2 over 1 plus G1, G2, H1. You substitute for each of them, and then you substitute for the values for K, Km, and Kp. And then once you have that now, then you have an expression in terms of input and output. Theta in over theta out is equal to that. And then you could substitute. If I tell you a sudden input change of 5 degrees, that is a step input, but instead of voltage, it's a positional input. So it's going from 0 to 5 degrees. But the same approach, if you have to take the Laplace transform or something like that, the Laplace transform of that will be 5 over S. It doesn't matter whether the step is a rotational step change, an acceleration step change, or a voltage or a current step change. The answer is the same. All right. Again, this was to lead to some other things, but the main issue again was just to simplify the block diagram, but lead to the usual thing is that this is part of another problem that you'll have to solve later on. Okay. So in terms of the midterm, tomorrow, the midterm, like the one last week, is open book, right? Open notes. So you come in, we are having it in room 8, there's our homeroom there. So you can work with everything that you need to work with. It is a 90-minute exam. You'll have some questions to answer, and everything is based on all that we did up to block diagrams. Okay, I think there's 4 questions that you have. So 4 questions with some parts inside of there. So everything that we did, the signal manipulation, you know, flipping signals around and inverting them, those kind of things. The convolution, of course, which we did. So simple convolution inside of there, block diagram, simplification, and then the lecture that we did with things like first and second order responses and so on, right? Just like this, if I tell you such and such is a step response to a system, if I tell you, I give you a second order system and I tell you I put a step input to it, what sort of response to give me a drawing of what the response would look like. You remember the second order system, you could get that kind of behavior in response to a step, right? What is that? What causes that, right? And there was a lecture that we did on that kind of thing. And of course, the block diagram, which is where it ended. Okay. So it's 90 minutes open book. So you have this stuff available to use. If your mind goes blank temporarily, you could just quickly go back and so on. Of course, you have to work out the solutions and so on. I'm not going to ask you something where you could just simply go to the notes and copy the answer, but you have them there in case you need to quickly check something. Yeah. So any last minute questions or any last minute concerns that you might have? Right. If you have anything that suddenly crops up during the course of the day, you could pop me an email and I'll check it out and try to get you back an answer as quickly as possible. Yeah, nothing. You all right? All right. So I put up a notice for those of you who are doing the ECNG2011 class this afternoon. Dr. Puran Singh has some presentations going on. So he asked for some extra time in case. So we will run the class from 3:30 this afternoon instead of 3 o'clock. Right, so we'll shift everything down by half an hour. So 3:30 to 4:30 for those of you doing ECNG 2012 this afternoon. Same online. All right. Okay, so I hope to see you all then. And well, tomorrow afternoon we will have the midterm for this class. All right. So if there are no further questions, let me stop the sharing. And I'll see you all later on this afternoon. Okay. All right. Bye. Take care.